Let's solve a different kind of problem. And from this problem, what we're going to do is look at this kind of weird relationship or pattern that comes out of a certain type of triangle. So let's just go ahead and kind of solve this problem, and then I'll talk about the kind of weird thing that happens. So if I got a triangle ABC, let me draw one. Okay, and let's call this A, this one B, and this one C. And it says angle A is 18.21, so let's call that 18.21. And side length A is 5, and side length C is 12.6. Okay, so if I have to solve for angle C and B, let's find C first. I can use sine law because I know the length across C, and I know A and its length across A. So I'm going to say sine of C over 12.6 must equal sine of 18.21 over 5. Okay, so if I isolate and solve for C, I'm going to multiply both sides by 12.6, so I get sine of C equals this stuff times 12.6. And if I crunch the right side out, I'm going to get this sine of C is about, what we got? Let's round it off here. We got 0.7875. Okay, now normally if I want C, I can just crunch this out, right? I can go sine inverse of C and get this angle. But have a look at this statement now. I could find an angle here, but there are, because of our cast rule, we've seen now that there are two solutions here. There are two angles that would be true for sine of C to give me this positive 0.7875. And before I start calculating those angles, think about our cast rule. So notice the sine ratio is positive here, and so that would put one of the angles in the first quadrant, which makes sense. It's less than 90 degrees, and that should be less than 90 degrees. But it puts the other angle that's possible in the second quadrant, because that's where also sine is positive, in the second quadrant. Okay, so that's kind of, there are two angles here, and they're both less than 180 degrees. So they're potentially, if they're both less than 180 degrees, potentially can exist in a triangle. And this is only true for sine because when cosine is positive, we've got an angle that's humongous. It's between 270 and 300, and that wouldn't exist in a triangle. And same for tan. When tan is, if we had to do something with tan, that would also be more than 180, and that can't exist in a triangle. So this is only true when we use the sine law. Okay, so let's go find the first angle. So angle C, I'm going to go sine inverse of this number, and I got 52 degrees. Okay, so 52 degrees is one of them, and that would be this angle right here from my diagram. Look, I've drawn this diagram in this particular way, so that would be 52 right in there, because it looks like it's an acute angle. But I could have drawn this diagram different. I just drew it that way. Think about, we're going to calculate this other angle in a minute, but think about what's going on here with the side length. Like this angle is 18.21, which means that like this side length kind of juts out at that direction compared to this direction. Like those two are set. That angle can't change. This length is 12.6. It's got to stay. It's always 12.6. This length is 5. It's got to be 5. But this length is unknown. This angle is unknown. So technically, I could have drawn the triangle where I had this also to be 5. So I could have drawn this diagram because I don't know what this length happens to be. It could be long, it could be short, I don't know. And I don't know what this angle is, so it could be big or it could be small. I don't know. So I've drawn, so this kind of, if I forget about this side of the triangle, I've now drawn this triangle. Let me just reproduce it down here so you see what I'm talking about. Okay, so this is A, and this is B, and this is C. So this is kind of a bigger angle, right? It's bigger than 152. It's bigger than 90 degrees. And what we do from our work from the other day, we already know how to calculate this. That if this is the acute angle in 52 over here in my diagram, then this also has to be 52. and then my other angle that satisfies this equation is 180 minus 52, which is 128. So there's really two possible triangles here that can be made from this kind of setup. I've got this triangle where this angle is 128 degrees, and this has a short length. This is still 18.21. This is still 12.6, and this is still 5. And then this angle in here would be very small. It would be the remainder of the 18.21 and 128. And I also got this original triangle I drew. It's possible that I've got a really long length here, and this angle is small. It's 52, and this angle would then be big. Okay, so I've got kind of these two different possible triangles because of this cast rule about the two different angles that would fit in there to get that ratio. I'm going to stop the video here. I'm going to make another video underneath to show you kind of another diagram that kind of explains this a little differently.